Okay, this video is for 11.7. Some people ask questions. Sorry. So, how do we start this? If you remember from chapter 10, this is like the last thing that we did when we were last in school. Oh, glory days. And we set up a chart. And then we did perimeter ratio, which is one-dimensional. We had area ratio, two-dimensional, that's a 2. And then we have volume ratio, which was three-dimensional. We're going to be doing that same thing to figure out what would the volume of the smaller one be. So this is my information given. The surface area of two shapes, similar shapes, it's already telling me it's similar, and the volume of the larger one. I have to figure out the volume of the smaller. So this is all with ratios. I don't have to use any formulas with these. Both of these are area, so I'm going to put this in the area ratio column, because these are area, surface area. You want to see if you can simplify the fraction. If you can, you should. If you can't, then that's fine too. And I'm looking, I can simplify this fraction. This fraction simplifies to be 1/9. See how when I simplify that fraction, I still keep it in my area ratio column, because all I'm doing is simplify the fraction. Now, if I'm going from area, which is two-dimensional, to perimeter ratio, one-dimensional, you have to move backwards before you can move forwards. So if I have something squared, opposite of squaring something is taking a square root. If I take the square root of the top, square root of 1 is 1, square root of 9 is 3. Now I use this to move over to my volume ratio. So in this case, I'm going to take my, that's a 3, perimeter ratio and cube it because it's three-dimensional. So if I were to cube that, my volume ratio would be 1/27. This is what I use to help me find volume. You have to have your volume ratio before you can do anything with your volume. So I have 1/27. That's my volume ratio. Now that's going to be similar to what is given. My larger volume is given, so that should be straight across from my larger ratio. And I have to figure out my smaller volume. So here I'm going to get rid of this division. Opposite of dividing is going to be multiplying. So I multiply the 432 over, I multiply the 27 over, and then I can do 432 divided by 27 to solve for x, and I get 16. My units here would be 16 meters cubed. This should have been cubed because it's volume. So that's the first problem that people had been asking. The next question was, how would I get to my surface area or my perimeter ratio if I have volume? So again, if I set up a little chart, perimeter ratio is one-dimensional, area is two-dimensional, volumes three-dimensional. We have this. And if I want to move backwards, you have to take the cubic root. So the cubic root would be this. Now, if you don't know where that is in your calculator, I will show you. However, I only have a scientific calculator. If you don't have a scientific calculator, you have to look for this button right here. Once you type in that, you have to push the 3 first because you want the cubic. This 3 would be the same as this. And then you would type in that button with the X value. But I'm going to show you how to do it in your calculator if you have the scientific calculator. I'm actually going to show you two ways to do this. So if I go to this math button right here, and then I can go down to this. This one's already the cubic root, and I'm going to push enter. And so first thing I'm going to do is do the 125 because that was our top number. So 5. So this would be equal to 5 on top. And then I also have the 5 disappeared, but 5 on top. Another way that you could do this is you still go over to math, and this is where, if you don't have that scientific calculator, you're looking for a button that has this right here. So if I type that in, now I have a spot where I can plug in my 3 because I'm looking for my cubic root. However, if you don't have a little spot, you have to type in the 3 first. And then I type in my 343, push enter. So my scale factor here would be 5/7. So that would be my scale factor, doing your cubic root. And the last question that people ask is kind of putting the first two together. I'm not going to show you again on your calculator, but first I'm going to write up my chart. Perimeter ratio is one-dimensional, area two-dimensional, volume three-dimensional. I have both of my volumes, 3 over oh my gosh, 375. I can simplify that to be 1 over 125. So again, I want to take the cubic root of that. The cubic root of 1 over the cubic root of 125. And if you do that in your calculator, that will give you your perimeter ratio, your scale factor. Perimeter ratio, scale factor, same thing. So 1 over 5. Now to move to area, I square that because it's two-dimensional. So I have 1 over 25. Now this is what I'm going to use. 1 over 25, and the smaller surface area is going to be on top over my larger one. So I have to figure out my larger. Same thing here, I have to multiply this over. So I'm going to multiply my x over, I'm going to multiply my 25 over. And then actually the x is already by itself. So I have that, the surface area, of the larger one would be 100 feet squared. That's a 0. And there you have it, 3 problems from 11.7. Thank you. Have a great day.